Question 9. This question is about time of flight, TOF, mass spectrometry. Give the equation using state symbols for the formation of SR plus ions from SR atoms by electron impact ionization. So it's going to be SR grams, arrow, SR plus grams, plus E minus. Remember, for electron impact ionization, the equation is X in grams, arrow X plus grams plus E minus. In this case, we've got SR grams, arrow SR plus grams plus E minus. Then it says a sample of strontium analyzed by TOF mass spectrometry. Sample is ionized using electron impact ionization. Ions accelerate to have a kinetic energy of this. So we know that's the kinetic energy. An ion takes this long, so that is time, travel along. So this is the distance, the length of flight tube. Deduce the mass number of this ion. Okay, that's all we're given. Well, what can we do? Let's get rid of this. There we go. So what can we do? Well, we've got kinetic energy. Let's think about it. We've got KE. We've got the mass. No, we don't have the mass. We have the length, velocity, distance, and time. We've got kinetic energy. We have the time. We have the length in centimeters. Obviously, we want it in meters, so we'll divide by 100. We want to find a mass number. And what we can do is, well, we can find out the velocity, then substitute velocity to find mass. Then once we find the mass of the ion, we'll times it by Avogadro's constant. Okay, yeah. So we know. So that's how I would do it. What are the two unknowns? Mass and velocity. Well, we can quite easily find out velocity. Velocity is distance over time. Velocity is equal to distance, 95 centimeters, divided by 100 in meters, 0.95 meters, and 0.95, all over the time, which is 9.47 times by 10 to the power minus 4. Therefore, we get velocity is equal to 1003.16789. Now we rearrange this equation, k equals a half mv squared. We get ke equals a half mv squared, 2ke over velocity squared equals the mass. That's what we're trying to find. So therefore the mass is equal to 2 of the kinetic energy, which is 7.02 times by 10 to the power minus 20. All over, should be big 2, yep. All of velocity squared, which is this number, which we just found out, velocity. So 1003.16789 squared. We get the m is equal to 2 times by 7.02 times by 10 to the power minus 20 over 1003.167 all over brackets 1003.167899 squared. We get 1.396 times by 10 to the power minus 25. That's obviously in kilograms. But remember, the mass number of an iron, mass of iron, it's got to be in grams. So therefore we've got to times this by 1000. That'll give us m is equal to 1.396 times 10 to the power minus 22. And that's in grams. And that's not the mass number. In order to find the mass number of the iron, we need to times by Avogadro's constant. 9 times 10. To give you Avogadro's constant, you have to use it. So for the final step, we need to times by Avogadro's constant, 6.022 times by 10 to the power 23, and we get mass number is equal to 84. 4.06712, so we'll just say 84. Then it says, explain how the ions are detected in thermoflash spectrometer. So how are the ions detected? Well, the ions hit the detector, and each ion gains an electron, generating a current. And how is relative abundance determined? Well, relative abundance is determined by size of current. Current is proportional to relative abundance. Okay. How ions detected? Ions hit the detector. Each ion gains an electron, generating a current. Relative abundance determined by size of current. Current is proportional to size of abundance. No, current is proportional to relative abundance. And then 9.4 and then 9.5. 9.4, sample of strontium. It contains 3 isotopes: 86 SR, 87 SR, and 88 SR. 82% of the sample is 88 SR. The other isotopes in the 1:2 ratio, 86 SR to 87 SR. Calculate the percentage abundance of 87 SR in this sample. So we know that, how do we find out the abundance of 87 SR? Well, we know 82%, this is the percentage abundance of 88 SR. So if we know the total percentage must be 100. We do 100 minus 82, we get 18%. So we know we've only got 86 SR, 87 SR, and 88 SR. And we know 88 SR is 82%. So the remaining 18% must be split evenly between these two. Not evenly. And we know that in a 1:2 ratio. So what we can do is 18 divided by 3 should give me 6. And because we know that it's in a 1:2 ratio where 87 SR is a 2, we're going to times it by 2, which should give me 12. And that makes sense, because if that's 12, Then 86 SR is a 1, so we divide that by 2, that must be 6. And 6 plus 12 equals 18, which is the remaining percentage. And 82 plus 18 would give us 100. So, yeah, that's correct. 12%. The reason I had to remove all of it because I'm gonna need space for this. Now we need to deduce the relative atomic mass of the sample. So we can say AR is equal to 88 times by 82 plus because now we've got the percentage abundance of 87 SR, which is 12%, we can easily find out the percentage abundance of 86 SR divided by 2. And we get 88 times by 82 plus 87 times by 12 plus 86 times by 6 divided by 100. And we get 87.8. 87.8. This bit would slightly trick people out, including myself, but just understand it's a 1 to 2 ratio. Total percent must be 100. 100 minus 82 is 18. 18 divided by 3 is 6. And if we're trying to find 87 SR is 2. So, and then 6 times by 2 is 12. Now we know 86 SR percentage abundance, 87 SR percentage abundance. Substituting to just create 88 times by 82 plus 87 times by 12 plus 86 times by 6 over 100, and get this. Electrospray ionization energy is used. Electrospray ionization is used instead of electron impact for the ionization of a protein in a mass spectrometry experiment. Suggest why. Protein does not break up / fragment. That's why electrospray ionization is used instead of electron impact for the ionization of a protein, because a protein ion does not break up / fragment. That is the end of question 9.